Hello, and welcome to the April 2021 Tech Talk IoT Platform Migrations Made Easy with AWS IoT. We have a great session planned for today. We look forward to sharing our content and answering any questions you have at the end of the session. To start, just a few quick introductions. First, my name is Lowry Snow, and I'm on the AWS Worldwide IoT Business Development team. Later in the session, I'll be joined by two additional presenters. First, Matt Stanlake. He's head of the Americas IoT Solution Architects team. And second, we have a very special guest joining us from Belkin. Daniel Koo is Director of Cloud Development and has firsthand experience migrating to AWS IoT. And we look forward to hearing details about their migration project. With that, a quick overview of the agenda and outcomes of the session today. We'll be covering three important topics that are related to IoT platform migrations and AWS IoT. First, we'll go over common challenges that companies often encounter as they manage an IoT platform and connected devices at scale. Second, we'll walk through a typical IoT migration journey and the phases and steps in the process from beginning to end. And third, we'll cover ways that AWS can help accelerate an IoT migration journey. And finally, Daniel Koo will join and share the Belkin journey as they modernize their own IoT platform using the IoT services. To kick things off, we start with an overview of the growing IoT device landscape. And yes, the numbers are continuing to rise significantly. The smart analysts out there are now projecting approximately 125 billion connected IoT devices by 2030, which represents around 1.3 trillion in revenue related to those IoT devices. But what does this mean to you as a company or a team or a product owner managing a connected device or an IoT platform? What this means is that you can expect that if you've successfully launched a connected product that's out in the market today, that you'll probably be building and launching additional connected products in the future. And what this highlights is the importance of being able to effectively manage your connected products at scale. Because any issues or pain points you're experiencing today will only compound as you add more devices and product lines to your current IoT platform. And that compounding equation is directly related to what we call the innovation snowball. For those of you out there that have successfully launched an IoT device or product, the good news is that you've overcome significant technical hurdles to get a product to market. And props to you for that tremendous effort. But we've seen that the journey doesn't stop there, even though that would make life a lot easier. The connected product innovation snowball occurs after a company launches a first successful IoT product. That first connected product eventually turns into the next 3 products, and then the next 9 products, etc. As customers, consumers or enterprise, product managers, business owners ask for more innovation and connectivity capabilities that are added to devices and solutions. And from one perspective, this sounds great, right? Because an organization now has many connected products that are launched and available in market. However, many people in organizations underestimate and fail to understand that the complexity of managing a connected software stack only intensifies and compounds with each new product launch. At the core of this complexity is the IoT platform, or the connected software stack. As new products are launched with new chipsets, processors, radios, etc., the platform has to be extended to support new hardware and new platform functionality. And as companies launch and are managing multiple connected products, various pain points start to surface, especially as device counts go up. And these challenges or pain points are often what prompt companies to look at ways that they can modernize or improve their existing IoT platform. So from the many customers that we've worked with and listened to over the years as they engage with us and ask for assistance with their IoT platforms, we see companies grapple with several challenges, typically falling into one of these 5 categories. First is scalability. Many companies worry about the ability for their existing IoT platform to scale as customer usage increases and as more devices are added to their platform. Managing the life cycle and updates of their device fleet becomes increasingly difficult, which raises concerns about downtime and quality issues that could impact customer satisfaction and experience. Second is what we call technology upheavals. There are frequently changes in the technology industry or the technology landscape that require a company to change their IoT platform. Most commonly, we've seen instances where third-party vendors close down or sunset their IoT platform offerings, and this requires a company to find and migrate to a new IoT solution. Third is security. Customers continue to rank security as a top concern for their IoT or connected device architecture and are willing to invest in order to modernize their IoT platform to better protect their customer data and, of course, their brand. Fourth is speed of innovation. Some platforms can actually hamper or slow down the ability to easily innovate and add new features, making it necessary to move to a platform that's more conducive to long-term innovation. And finally, cost concerns. Cost is often cited as a primary concern with the use of expensive third-party solutions and platforms. We've actually seen instances where we've helped customers save up to 90% on per connected device costs by migrating to the AWS IoT Services. At a fundamental level, the biggest issue with legacy or old platforms is that they can actually be a barrier to the goals and plans of an organization as it relates to their connected product strategy. We have on this slide just a few examples of companies that have confronted some of the challenges that I mentioned in the previous slide, and how making a commitment to modernize their IoT platforms, they ended up removing barriers that ultimately allowed their teams to focus on ways to improve the customer experience instead of having to manage that underlying and undifferentiated IoT infrastructure. Here are just a few concrete examples of additional benefits that customers have derived by migrating to the AWS IoT Services. Traeger was able to cut their per connected device or per connected grill cost by 90%. LG was able to save 80% in development costs, which freed their resources to focus on product innovation. And for anyone out there that has an LG OLED TV, you know firsthand how great that innovation is. And finally, iRobot was able to significantly improve the stability and scalability of their platform, again, allowing their developer resources to focus on more interesting things that improve the customer experience. So as we work with companies that are considering an update to their current IoT architecture, and as we help them plan a successful migration strategy, we typically encounter 3 common migration scenarios, which will probably fit your use case as you look at migrating your own IoT platform. First is the next generation migration scenario. This is where a company decides to migrate to a new IoT platform for new or next generation devices, but they leave the legacy platform and brownfield devices untouched, allowing the old devices to reach end of life without any significant updates to the firmware or to the connected software stack. All new or next generation devices then ship with the new IoT platform where the organization is now 100% focused. Second is the brownfield migration scenario. In this scenario, there are cases where the live or active infill devices, also referred to as brownfield devices, those devices require a complete IoT platform or connected software stack refresh. In this scenario, the customer migrates the brownfield or live IoT devices to a completely new IoT platform using the AWS IoT Services, while those devices are in the field and in use by customers. This is often necessary when third-party IoT technology is sunsetted, or when there are serious technical problems that are impacting the customer experience, or when a customer wants to reduce per device costs. And third is the hybrid migration scenario. So there are various cases where an organization doesn't want to overwrite their entire IoT platform, but they identify reasons for enhancing the brownfield IoT stack with elements of AWS IoT while they work on an entirely new next generation platform for their new connected devices. In this scenario, customers may update their existing platform in order to gather new data insights from old devices or to improve security architecture, such as adding the AWS IoT Device Defender service to make their existing devices more secure. And we have various examples of customers that have migrated to the IoT services from each of the migration scenarios that I previously mentioned. But today we're fortunate to have Belkin join us later in the session to share more details about their migration experience, what were the reasons they migrated, what were the ways that AWS assisted, and some of the benefits that they derived by completing a successful migration. And now we move to the more technical portion of the session. Matt Stanley will join and share details about the IoT services and typical migration patterns. Over to you, Matt.
Thanks, Lowry, for the introduction there. What I want to go through is a little bit about our IoT services that help deliver on this migration. Before I get to the services themselves, I want to spend a little bit of time and talk about some of the benefits that customers of ours have seen building their IoT platforms on top of AWS IoT. These sort of go hand in hand with some of the concerns that Lowry has just raised before. I'm going to start with the long-term stability. AWS has been in the IoT game for many years now. We continue to invest in this, and we can give you that peace of mind knowing that we're going to be here as your platform evolves in the future, and we can continue to support that as we move forward. We're also, we have the scale that you need to make sure that you can support the millions of connected devices that you might have, as well as the geographic reach. It's actually quite interesting. In December, our VP of IoT shared some of the metrics around the scale of our infrastructure. Every month, we have 500 million unique endpoints connect to our AWS IoT services, and we handle over 500 billion messages. That scale that we get from all of our customers connecting to our services helps us save you money through the economies of scale that we're able to drive. We can come up with, we can provide solutions which are a lower cost than most DIY simply because of the mass scale that we have behind us on this. Throughout everything that we do, building out our platform, security is job zero. So starting with the embedded development environment, or the embedded environment, through the connectivity stack that we use to get data to the cloud, through all of our cloud infrastructure and all the connection to the other AWS services. We make sure security is paramount, and it really is sort of the forefront of most of our decisions to ensure that any platform built on us has that secure underpinnings that you need. And I think the last and probably most important benefit that you can see from working with AWS IoT is it allows customers like yourself to innovate faster and to become more agile, because you don't have to worry about all of that undifferentiated heavy lifting of running the IoT infrastructure. Rather than having teams of people making sure that the message broker is going to stay up and running, you can focus on the things that are adding value to your customers instead. You can try out new features. You can try out new services. So these are just some of the things that we benefits that we've seen customers gain through this working with us in IoT. The way we deliver this is through a suite of IoT services. So it's not just one service that we deliver. If we start at the device software, we have FreeRTOS, which is currently the leading real-time operating system, which comes embedded with the connectivity tools you need to connect to AWS IoT. If you're using a different OS, we have our IoT device SDKs that allow you to connect devices up to the cloud. And we have Greengrass, which is our edge compute environment that allows you to start to do more powerful edge applications. Once we get the data from the devices, it connects up to our connectivity and control services. IoT Core, Device Management, or Device Defender. This is where the actual management of your devices happens. This is the fleet management aspect. This is where we can secure and make sure that we don't have any devices that are doing anything that can harm the system. We get the data in through here. And now, once the data is in the cloud, we can expose it to our analytics services and really turn that data into actionable information with services like IoT Analytics and IoT Events. The output from that, the decisions that we can make from there, we can then drive back into our device software and start to actually have this virtuous cycle of data coming from devices through the cloud and then updating and improving the system as we go. This is an example architecture or reference architecture that we've put together for one of the scenarios that Lowry mentioned above, our hybrid platform migration. I'm not going to go into details on every box on here, but I think it's important to sort of see how we can connect the pieces together, connect those different services together to be able to deliver a holistic solution. Another important aspect here, one of the benefits of AWS is that we have that seamless access to other AWS services, API gateway, SNS, the simple notification services, Lambda capabilities. So once you're in the ecosystem, you can expand that out and leverage the entire breadth of the AWS environment. So I want to turn a little bit now and sort of say, start to look at what's the migration journey look like for some of our customers that have migrated onto AWS IoT. The first thing that we need to cover is every IoT platform is different. We've joked internally, it's like snowflakes. Every snowflake is unique, so is every IoT platform. And the reason for it is because every one of these platforms has had unique requirements put upon it and unique constraints. And we can't come up with a one-size-fits-all approach that's just going to have that easy button that we can press and magically migrate. We do need to sort of understand what's made the platform the way it is. To help that, we've created a typical migration journey, and we've used this with multiple customers to help move them from their legacy platforms to AWS IoT. It's a three-step process that we use. We start with a migration assessment, where we really understand those constraints. We understand those requirements. We have a readiness and planning step where we start to explore how can we implement the changes? What processes do we need to put in place? What governance do we need to have around this? What's the timeline, regions that we're going to do this? And then we actually have the migration and modernization step at the end. Through all of these tools, AWS has multiple other capabilities that we can deliver to help make sure that this goes smoothly. I'm not going to go through detail of all these, but we've built up a library of tools to help us through each one of these steps. Some of the best practices that we've seen as we've gone through this, one of the big ones we've found is making sure that we share the ownership of the migration with customers. So it's not something that if we expect that customer is just going to do independently and they're going to go and just move all the stuff to AWS IoT. We take a partnership approach, and our account teams, so our account solution architects, our IoT solution architects, our account managers will work with the customers, understand their needs, build out an architecture. So each one brings different knowledge. So we can bring that deep knowledge of AWS. Customer brings that knowledge of the platform. We combine those to build out what's the plan, what's the vision. We also often want to bring in a migration partner to help with the implementation detail, or our professional services organization to make sure that we can execute that successfully. So making sure that we have the right people at the table is one of the most important steps in a successful migration. Another thing that we've found has worked very well is taking a stepwise approach to implementing the migration. We want to start with a pilot and prove out the technology, prove out the capabilities, and it's going to deliver what we want it to in the end. So we want to go through, get that pilot working, scale that up a bit, do an MVP, maybe it's a smaller region that we'll do, before we go and do that full rollout. What that allows us to do is it allows us to ensure we have that strong foundation that the migration, when we execute it, is going to be successful. So it allows us to make sure we've got the technology issues worked out. It allows us to make sure that we've got the architecture in place and that we have the right migration strategy to move forward. It's sort of that typical crawl, walk, run approach of doing this. We want to make sure that we go through this so we're successful in the end. So we're often asked with this, oh, okay, great, I'm interested. Where do I start? What's sort of the process with that migration assessment? So when we look at this, the migration assessment focuses not just on the technology or not just on the business. It really needs to look sort of holistically at both. As I mentioned earlier, it's understanding the requirements that drove this and understanding those constraints. So some of the requirements we need to understand is what's the business value that we're delivering as part of this platform? Who's involved in this? Who are your customers? Where are they located? Where do you expand? Where are you expanding to? So we can make sure that we've got the right coverage. On the technology side, we need to understand what are the technology constraints. What's the type of chips that you're running on the device? Can we push down different firmware to those devices? How are you operating it? Is this something that you have a DevOps team? Are you outsourcing this work? So we need to understand all of these components. What that allows us to do now is to create that readiness assessment. So both we in AWS and you as a customer understand what's it going to take to get from where you are today to that platform of tomorrow. At this point, I want to transition back to Lowry, who can start to go into more details around the specifics of what AWS can offer to help in this process.
Thank you, Matt. So if you're still listening out there and your team is interested in embarking on a migration journey, and you're interested in how you can enjoy the benefits of the AWS IoT services, what does AWS offer to assist in your migration journey? To help accelerate your IoT platform modernization project, I'm going to go over 3 services that we offer today that would be of interest to different organizations based on where you're at in the decision-making process. But before I jump into the details, I want to highlight and call out that these things here are complementary offerings, aka no cost to your organization to take advantage of these benefits. So I highly encourage you to give these things some consideration. First, let's start with the IoT Innovation Lab for migrations. The IoT Innovation Lab is something that we launched a few years back to connect AWS IoT experts with technical and business stakeholders at companies that would like to ideate and build with the AWS IoT services. Specific to migrations, we offer an IoT Innovation Lab for customers that want to bring key stakeholders together, both on the business and technical side, to move a team or organization toward a decision to migrate and to assess the benefits and value of modernizing the IoT architecture that's in use at a company today. Next, working with the AWS ProServe team, we provide a complimentary IoT migration discovery and design workshop, which is typically 2 to 4 days based on customer needs, with a focus on understanding your IoT architecture as it exists today and doing a deep dive on what a modernization and migration project and plan would look like using the IoT services. The outcome of the free migration workshop is the following. First, a proposed architecture for a migration project. Second, a delivery milestone roadmap. Third, a breakdown of a migration project with cost estimates. And fourth, a skills matrix that's mapped to the skills and competencies at your organization. Those assets I just mentioned will be resources that can be used by your team if you'll be doing all the migration work yourselves, or they can be used as a blueprint for the ProServe team or a partner to follow that will help accelerate your modernization project. And last, if you or your organization prefer to do the migration work on your own and want to jump right into a technical deep dive on the AWS IoT services and how to build an optimal IoT architecture with AWS, the IoT Solution Architecture team provides a complimentary IoT Services immersion workshop to educate you on the IoT services, understanding your current architecture, and will help outline a plan for a successful migration project. As we commented earlier in the session, a best practice for a successful migration project is to select and work with a qualified AWS partner that can assist with your migration journey. And we have advanced AWS consulting partners with established practices that are ready to assist you and your teams in each of the regions around the world. If this is a path that is of interest to you and your team, we encourage you to work with your AWS account contacts to get introduced to a partner that best matches up to your unique technical and business goals. I'll also call out on this slide that we have funding programs that are available to mitigate the costs associated with an IoT migration, and we can actually help pay the partner that you select to assist your company and team with a migration project. And often the amount that we pay the partner is a significant portion of the overall migration project. In addition to the complementary services that we provide to help with your migration project, including the IoT migration and immersion workshops that I mentioned earlier, AWS has several programs we can help you leverage to help offset the cost to modernize your IoT platform. These offerings include, number one, programs such as MAP that provide significant savings and incentives to companies that migrate from other platforms to the AWS IoT services. Number two, we can easily provide IoT and other AWS service credits to your team and company as you plan and develop a POC and as you plan for a production rollout. And third, as I mentioned in the previous slide, we have mechanisms available to fund the AWS partners that are available and excited to help accelerate your IoT modernization journey. And now we are fortunate to have our special guest, Daniel Koo, join us from Belkin to share his firsthand experience as they planned and executed a migration to a new IoT platform with AWS IoT. Daniel, over to you.
Thank you, Larry. My name is Daniel Gu. I work for Belkin, and I'm the Director of Cloud Development. So first thing first, I would like to introduce what Belkin does. Right? Belkin is known for their consumer electronics and accessory. Most of you probably have seen Belkin's product in either the airport kiosk or a mobile app store, accessory stores. Right? You see those bright blue fancy case or cable. But on top of that, Belkin also owns two brands. One is Linksys, one is WEMO. And I'm here to talk about the WEMO's migration process to AWS IoT. Let me introduce what Linksys product has. Linksys is a very old brand, and everybody probably knows Linksys is a consumer networking company. We have many different kind of router, wireless router, switch, cable, modem, basically adapter, anything you can think of wirelessly. And WEMO, on the other hand, is a smart home product company. And this brand has existed for more than 10 years. We are a very early adopter of all the smart home technology, including Alexa, Google Home, that. Here are a couple of samples of the product. We have outdoor plug, which lets you connect to control your devices outdoor. We have dimmer, and we have a different form factor of the plug. This list is actually chronologically listed. So these three are the newer devices. We have a three-way switch, smart plug, light switch, and the bridge that you control all the HomeKit devices from Apple. All right, I'm giving a quick statistic about the usage of our product and the consumers in the cloud. In 2020, right, we have over 1.2 million accounts registered and over 1 million network registered provisioned. every day we average about 3,000 new customers coming in and register their account. As of the app usage, we have an iOS app and Android app. So 37,000 iOS app logging and usage and 16,000 Android app. We also have a web UI, but you all know nowadays most people just focus on their mobile app and rarely use the web UI. So overall, we have about 8 million accounts and about 5.5 million networks that is in our system. It's quite a big cloud system, right? So the next, I want to give a quick introduction of our cloud architecture. Right? Since this is a technical webinar, it doesn't make sense to not showing a fancy cloud architecture. So Belkin has been using AWS for over a decade, since 2010, even when it was still in beta. So we are a very mature user of the cloud, and our architecture and the challenge differ from those startups or other companies switching to the cloud, where we need to maintain a legacy service while innovating for the future ones. Right? So what you see here, all these services, a lot of them are developed way back in 2010, 2011 when we first started. And not only a lot of time what we are spending here is optimizing, finding efficiency, and trying to understand not only the customer's behavior, but how our product functions. So that's why when you see these partners here, right, it actually gives us a different perspective when we are looking at the AWS products. Okay, so let's dig into this slide here, right? So on the client side, of course, we have a mobile app, and our front end mostly is developed with HTML5. We are a very service-oriented architecture company, and all our cloud is based on these microservices, serve different needs. On our device side, our hardware side, right, our router is running the Olympus firmware as well. Our WEMO is running on Linux platform, as well as the AWS FreeRTOS, Amazon FreeRTOS, which I will dig into a little bit later. On the back end, the data tier, we have different caching mechanism and CDN, content delivery network, for performance reason. On the storage side, we have file storage and NoSQL, and of course, the relational database. On the business analytics side, we've done a lot of SQL reporting, and we heavily use Splunk for all the other analytic troubleshooting and log aggregation. As I hinted earlier, I mean, all these years of cloud work, so we have numerous partners in our development work. They are like Salesforce, Alexa, IFT, Google Home, and we also manage subscription for our app. A couple partners worth noting here. Okay. All right. So this is a big technology tree that our cloud use. I probably just highlight a few that is AWS related, right? Like in the data stores, we use Aurora quite a lot. On these SNS for notification, we use AWS SNS quite a bit. For authentication, we use Cognito. For secret manager and the password encryption, that we also use. And the most important thing for remote access, we use MQTT, which is AWS IoT. Content distribution and the caching, we use Elasticsearch, AWS S3, CloudFront, and Redis Cache, all hosted in AWS. On the utility, we use different kind of utility. Almost everything you can probably think of, you find a piece of AWS in it. Right? ActiveMQ for event processing, SQS for queue and any asynchronous processing, and Event Bridge for scheduling. All right, so I think enough background talk. Now let's look at the two different stories I want to present today. Right, so this just give you a different perspective, right? How we use AWS and especially AWS IoT. There are some year-long project which is huge scale, a lot of people working on it, but there is also some little project that can help us to improve the efficiency in AWS. So the first one I want to talk about is the migrating the WEMO cloud to AWS IoT. This is a year and a half project. So I remember the slide I showed earlier. There are different WEMO product line, right? So in any typical consumer electronic company, the product life cycle is about 1 year. So every year you have to come up with new products, new SKUs in order to basically follow the trend, right? And people feel like, okay, they always want to update their product and buy new products. So we run into a couple of challenges when we follow this trend because we keep coming up with new product, keep coming up with, scalability and where people sign up is one thing, right? But just to, how do we keep it up to date? On the cloud side, right, scalability is what I mentioned, right? You can see that we have 7 million total customers among all the clouds. And also uptime, the maintenance, and the cost, and also the responsiveness in the app. All these things becomes a challenge for the legacy cloud. And I will use the next architectural diagram to explain what kind of difficulty we are facing in all 4 aspects. Okay, so this is the before when we move to AWS IoT. This is how our architecture looked like, right? So not the high level. This architecture only focus on the WEMO cloud. We have these legacy devices. They are Linux-based device, and our consumer needs to use app to connect to the cloud to control this device as well as receive the status update of this device. Also, our partners, Alexa or Google, they need to come to our cloud in order to get status or control these devices. So how do we maintain these blue lines, which is the remote access route, right? It is going through an ICE and a turn protocol. And we have to host more than 180 turn servers in our cloud. This is still in AWS, but it's just the standard EC2 instances. So as you can see, right, our DevOps team is really struggling. I mean, of course, like 10 years, we did a lot of improvement, but these are all manual process, ad hoc, right, where we see what is broken, we fix it. If there is one server go down, let's say the one app server is having memory leak and we need to recycle it. Often we have to, in a clustered environment, we have to take it out and put it back in with some kind of manual script. Right? From time to time, it just becomes much difficult to manage. So we come to, in the next generation of the product, which is the, like I hinted earlier, right? Every 12 months, we come up with a new product. We are looking for a completely different architecture. And MQTT come into picture here. We used to, I mean, we actually, before moving to AWS, before deciding on AWS IoT, right, we did quite a few POC. And we tested eMQTT, we tested the HiveMQ. We even trying to build a Mosquito server ourselves. But it all comes down to, do you still want to manually maintain that 180 plus brokers in a clustered environment, or you want to have a centralized resource and you can assume it has unlimited power. You can just, don't worry about the scaling, right? So I think Laurie and Matt also talked about this earlier, right? You can always just connect to the broker, no matter you are in different geologically location or anywhere. You can always connect to the MQTT broker. So on the firmware side, we move to FreeRTOS on the device. On the cloud side, we move to AWS IoT. But what about the app? The mobile app is also an important user interface, right? Most people don't see the cloud, don't see the firmware, but they do use the app every day. So responsiveness is a big key, right? Before we migrate, in the old turn server architecture, this is a request and a response architecture. Basically, you use the API to send the request through the turn server, you send it to the device, and you wait it to respond back. Let's say if you want to see the status update, you have to constantly pulling for the server status, right? Moving to a event-based architecture through MQTT, it becomes you subscribe, and whenever there is a status update through MQTT, it comes to AWS IoT, and the WEMO app gets the status update right away. So that's what I mean by responsiveness is a challenge earlier. Right, so we actually did 3 migrations. I'll go into the detail of each of them, but firmware, we moved to AWS FreeRTOS. Cloud, we moved to AWS IoT and the mobile app. So that's the phase 1 of the migration. So we'll look at the phase 2 in a slide later. All right, so now let's look at the transition to AWS IoT for phase 1 on the firmware side and on the cloud side. So on the firmware side, we are developing this new device, right? We put FreeRTOS in it with the AWS team's help. We actually is able to work with our chipset vendor and the ODM to come up to bring this FreeRTOS on board. At that time, I think it was quite challenging, actually. It took us about 2 to 3 months in order to get a working prototype. But eventually, we were able to use this, and it's connecting to the MQTT broker, to the MQTT broker in the AWS IoT core. Okay, but this is a new device we are developing, right? The current device, the legacy device, which we had 8 years ago, 5 years ago, they are still on the Linux-based platform connecting to the turn server. Right? That's why in the next slide, you will see that this is what I call the phase 2 move. We actually convert using the AWS device SDK, convert all this Linux-based device to the MQTT broker so they can enjoy the same benefit. So since earlier, we have already developed this. I'm switching back 1 slide, by the way. Since earlier, we have already developed this with the new device. We built out all the cloud using the AWS IoT core for remote access. So when in phase 2, when this device also connect to MQTT, we basically get this for free. There is no cloud change. Seriously, we convert the firmware 7 different SKUs. There's 0 cloud change required when we do this. And the consumer base is actually much larger because we had this cloud for 10 years, right? All these are legacy devices. 3 million of them, they are actually enjoy the new firmware update for the faster speed because we're converting to using the IoT core. And the Linux SDK is also very easy to adopt. They just work with the standard, the Linux OS. Yeah. Okay, so the next thing I want to talk about is the app transition. Like I said, right, the app used to get the real-time status update from the IoT, from using pooling, right? Now we're converting to AWS IoT core. So what we do is we have the app subscribe to the same status topic in the broker. When the device pushes its status update to the IoT, the app can receive the status update right away. And also, we use some built-in rules in the AWS IoT to trigger a Lambda function to build in all the status into the cache. It's very similar to the concept of shadow in the AWS IoT. By keeping the latest status in the DynamoDB, it allows the app to retrieve the first status list much quicker. Instead of going to the device and grab the latest status and wait for the device to respond, right? The mobile app just call the cloud, and the cloud just grab the latest status in DynamoDB. And so it gives the app the responsiveness to render this right away. Okay, and so this is the one that I highlighted earlier, right? So all the Linux device now connecting to the MQTT broker. So this line is broken. The only thing we still have left with our existing legacy cloud is the firmware update behavior. But we are also in the process of implementing this, right? Because using since the device is subscribing to the AWS IoT topic, so it's constantly monitoring. So we were able to push the firmware update command to the device right away, tell him that, hey, there is a new firmware available for you. And this part, we didn't use the fleet management. I know there's a function there in the AWS IoT core, you may wonder, right? It's just because we already have this mechanism in place and we decided to just keep it rolling like that. Okay. All right. So next one, I want to give you guys a very interesting example that we did, which is also a service provided by AWS that we start using and at the time when we are migrating to AWS IoT, right? So just like any of the DevOps team folks out there, right? You probably have the same problem as you have multiple environment from dev to integration to QA to stage to prod, and often they exist in different AWS account. Before, this is what I do. Every time we're having some problem in a certain environment, I have to find out, okay, take out my cheat sheet, find out how do I log into that particular environment. And as any of the modern company, usually you have an Active Directory. You have a bunch of already existed OAuth integration within your company IT department. So what we did is actually we use AWS Identity, which is a single sign-on tools with Okta. Right? What you see here is our intranet portal. And if you see this little box here, we can leverage our company's credential using single sign-on integrated with AWS Identity. It let me, after click on it, it will prompt me after sign in, right? Show me all the AWS account here. And when you click on it, it just takes you directly to the management console. And this probably saved me like 10 minutes every day of trying to figure out which environment I'm trying to log into to manage AWS IoT. And so it's really a time saver. So the point of here is really, it could be a big project like 1 year, or it could be a 1 month project, but it just gives us so much efficiency and convenience by switching or using the AWS service. Okay, so that's all I have for today. Thank you. I'll now transfer back to Laurie.
And thanks again, Daniel, for sharing your team's experience with a real-life migration story and how you moved millions of devices to AWS IoT. To wrap things up, as we said at the beginning of the session, the IoT landscape is moving rapidly, and legacy or older IoT systems and platforms can impede future growth and innovation. Customers are migrating to a modernized IoT platform to reduce costs, improve scalability, and to plan for the future. AWS stands ready to help accelerate your IoT migration project with direct support and funding options for partners. And we look forward to collaborating with you on this journey. So, are you ready to get started on a migration project? Or would you like to learn more and speak with an IoT expert directly? If the content in this session resonates with you, a simple next step is to request a session with an IoT expert so we can learn more about your use case, answer any questions you have, and help with your plans to modernize your IoT platform. In this slide is a link you can follow to enter your info, and we'll get back to you quickly to schedule time to meet. And with that, we thank you very much for your time today. And with the remaining time, we'll answer any questions you have about IoT migrations.